How many grams of sodium hydroxide would be needed in order to make 500.0 milliliters of a 6.0 molar sodium hydroxide solution? So, the first thing that I'm going to look for in this particular problem is I'm going to look for what concentration unit I'm having. And in this one I have a molarity. And the equation for molarity is molarity equals the number of moles divided by liters. So, I look for what I can plug in directly. I can plug my 6.0 molar in, but my volume's in milliliters, so I'll need to convert that. 500.0 milliliters. Well, there's 1,000 milliliters in 1 liter, so we end up with 0.5000 liters. These zeros that are following the 5, here, here, and here, are all significant and must not be dropped. So, if we look at our problem, we have 0.5000 liters. And now we can solve for the only number that we don't know, the number of moles. So to solve for the number of moles, I'm going to take my volume, my 0.5000 liters, to the other side. If I'm dividing by it over here, I'm going to be multiplying by it when I bring it across the equal sign. I do the opposite math operation. And that'll equal our number of moles, and that would give me 3.0 moles of sodium hydroxide. Now, the problem asks for grams of sodium hydroxide though, so I need to do a little conversion. 3.0 moles of sodium hydroxide. Well, if we convert from moles to grams, we need to use the periodic table. So in this formula, we have sodium, which weighs 23, oxygen, which weighs 16, and hydrogen, which weighs 1. So, sodium was 23, oxygen was 16, and hydrogen was equal to 1, which gives us a molecular weight of 40 grams per mole. So I can take my 40, put it into my conversion factor, and now solve to say that I have 120 grams of sodium hydroxide that would be needed in order to make 500 milliliters of a 6.0 molar sodium hydroxide solution. And that would be our final answer.